this video, we will be covering the Carnot cycle. In a cycle, something goes through a series of steps and then returns to its original state. The Carnot cycle is one of the most fundamental thermodynamic cycles you will learn. So let's start off with the cylinder, enclosed by a piston and filled with the gas at a known temperature, volume, and pressure. We'll start off step 1. So in step 1, we will apply heat from a large reservoir to the gas. Now the gas, we'll say, is at temperature TH. And the heat that is being applied to the gas is also at TH. Now as this happens, the gas will expand at a constant temperature and the piston will rise up. So step 2. The piston will rise. And the pressure in the cylinder will decrease and the volume will increase. Now, as this process from step 1 to step 2 occurs at a constant temperature, and that is also known as an isothermal process. So again, we have Q coming into our system. The gas expands and the piston rises. This all is occurring at a constant temperature. So the gas here is still at TH and the pressure has gone down as the volume has increased. Now we're going to take away this heat source. We're going to assume that our system is thermally insulated. So now that we've taken away our heat source, there is no heat exchange happening in our system. The gas will act as a spring and will continue to expand as it cools to a temperature we'll call TC, and the piston will continue to rise. So piston continue to rise, and then now the temperature in our cylinder is TC, less than TH. The pressure has continued to decrease and the volume of our gas has increased. Now from step 2 to step 3, there has been no heat exchange. This we'll call an adiabatic process. Again, this is where a process where there is no heat exchange. Now, as we go to step 4, now the surroundings will do work on the gas, and the gas will be compressed as the piston lowers. Here we'll have the piston starting to drop as heat now is being removed from our system. The gas inside is still at TC, but now the pressure has gone up as the volume has decreased. Now, at some point, the heat will stop leaving the system and the system will continue to compress and return back to state 1. So now this will return to state 1. So the process from 3 to 4 is again another isothermal process. Isothermal. And the process from 4 to 1 is another adiabatic process. So this cycle that I've just described has performed like an engine. We've converted the heat that has come into our gas at step 1 into useful work. Now we will plot the pressure versus volume for this entire cycle. So down here, we'll have a pressure and volume plot. Now, we'll start off at state 1. We start off with pressure at some volume. So now I would like you to pause the video and come up with the pressure-volume graph for this cycle. Okay, now that you've had some time to think about it, from point 1 to point 2, we see a drop in pressure and a drop in volume. An increase in volume. And in this, we have a Q coming in. This occurs at a constant temperature. From going from 2 to 3, we see a continued drop in pressure and an increase in volume. This process is adiabatic. So we go from 3 to 4, we see an increase in pressure and a decrease in volume. And then we'll go from 4 back to the original state at 1. Another thing that oftentimes is plotted for a cycle is a temperature versus entropy graph. So again, we'll start off with a point. So we have some this is our TH. Now going from 1 to 2, this was an isothermal process, so our temperature in the system stayed at TH, and the entropy in our system increased. Going from 2 to 3, we saw a drop in temperature down to TC, and since this is an adiabatic process, there is no heat exchange and our entropy stays constant. Going from 3 to 4, we now see a decrease in entropy as heat is leaving the system and the temperature stays at Tc. And then going from 4 to 1, we return back to the original state. So this is known as the temperature-entropy graph. Now this cycle is a model and is not possible to perform physically. The cycle was first developed to establish that an engine cannot convert all the heat energy from combustion into mechanical energy. In the next video, we'll go into more detail on calculating the efficiency of this cycle and a little more detail on these graphs. Thanks for watching. Bye.